Nonlinear inequalities. We're going to take a look now at solving inequalities, and this could be a linear inequality, a polynomial inequality, a rational inequality, and so forth. So the basic general steps is that step one is we're going to find any zeros as well as any vertical asymptotes. We're very concerned about the domain of our function. So we're finding any zeros as well as any time we're going to have a vertical asymptote or any other domain restriction. Those values are going to be known as key values. We're going to arrange those from least to greatest, and we're going to divide our domain into test intervals. And those intervals will have the key x values as endpoints of the interval. Then we're going to find some x value that's within each interval and evaluate the sign value of the function. Because whatever the sign value of the function is at our test point is going to be the same as the sign value for the entire interval. Now, it might not make sense to you yet because we haven't done a question. So I'm going to do a question with you that's very straightforward and very simple because it's a linear function. So in essence, what we're saying is our function is f of x is equal to x minus 1. And we're finding where is that function less than 0. So that's how I want you to think about this. So step one, let's find all of the zeros of the function. How do I find the 0? I take the function and set it equal to 0. So I get x is equal to 1. Now I only have 1, so arranging them from least to greatest is very easy, but I'm going to take my entire interval, or my entire domain, and turn it into intervals. Well, what's the domain of a linear function? It's all real numbers. So that's negative infinity to positive infinity. But I need to separate that out using 1. So I'm saying I've got negative infinity up to 1, and then I've got 1 on to positive infinity because my only key value was 1. So I took my domain, separated it out using that 1. Now from here, what I'm going to do is I should have left myself more room. Let me try again. Negative infinity to 1, 1 to infinity. And I'm going to come up with some number that's between negative infinity and 1, and just use the easiest number you can think of. So I'm going to use 0 because 0 is between negative infinity and 1. And between 1 and infinity, I'm just going to use 2. Now, you can use your calculator as we have in the past to plug in our function and then find f of 0 and then find f of 2. What I'm looking for here is what is the sign, because I know when it comes down to it, I'm looking for that function to be less than 0. So if I plugged 0 into this function, I would get 0 minus 1, which is negative 1. So I could write negative 1, but I'm just going to write negative because that's all I care about. Is it negative or positive? Now f of 2, we can't plug in 1 because that's the key value. F of 2 is in the interval 1 to infinity. I would get 2 minus 1, which is 1, which is positive. So the big question, what is my solution? My solution is that whenever x is in this interval, the value is going to be negative. So my solution is negative infinity to 1. Now you might be asked to graph the solution set, and that's very simple as well. I'm going to write 1, and then I'm going to shade everything to this side and leave an open circle at 1. Now you can, of course, add a few more numbers if it makes you feel better so that you understand that this is just a normal number line, but that is how we would graph. Let's take a look at a polynomial inequality. So just as we did before, we're going to start with step 1, which is to find the key values. And the key values are made up by examining both the domain restrictions and the zeros. So if I take a look at the domain is a polynomial, and a polynomial has no restrictions. So that's from negative infinity to positive infinity is my domain. For my zeros are determined by factoring. So I'm going to take x squared minus x minus 6 equal to 0, and then factor that. Numbers that multiply to 6, negative 6, that add up to negative 1 would be x minus 3 and x plus 2 equals 0. Notice I'm not putting greater than or less than 0. I'm putting equal 0 because I'm finding my zeros. So my zeros are positive 3 and negative 2. Oops, equals negative 2. So that's step 1. Step 2 is now to take my entire domain, which is negative infinity to positive infinity, and separate it out using 3 and negative 2. So again, keep in mind that you're going to put things in the correct order. So I'm going to go negative infinity to negative 2, negative 2 to positive 3, and from 3 to positive infinity. Step 3 is to come up with some value that's between the two ends of the interval. So a number between negative infinity to negative 2 would be a number like, say, negative 4. A number from negative 2 to positive 3 would be a number like 0. And a number between 3 and infinity would be a number like positive 4. Now, it's very important to keep in mind, you can choose any value and get the same result as long as the value is in that interval. So now what I'm going to do is simply find the sign. Now, you can find the value of the function if you want, so I'm going to give you a couple of choices. I can, using this negative 4 value, I can find f of negative 4, which would be negative 4 squared minus negative 4 minus 6, which would be 16 plus 4 minus 6, so 20 minus 6 is 14. I could also find f of negative 4 by plugging it into the factored form. Negative 4 minus 3, negative 4 plus 2 gives me negative 7 times negative 2, which is positive 14. The way that I prefer to do it, because I don't care that it's 14, I care that it's positive. So the way that I choose to do it is to simply look at the factored form, x minus 3, x plus 2, and determine the signs. So if I were to plug in negative 4, I would have negative 4 minus 3, that's negative, and negative 4 plus 2, that's negative, and a negative times a negative gives me a positive. So your choice, there's no one right way to do it. Notice here I determined it was positive 14. Here I determined positive 14. Here I didn't care about the 14, I just said it's positive. So let's continue now using 0. If I plugged in 0, I would have 0 minus 3, which is a negative, and 0 plus 2, which is a positive, and if I multiply that, I get a negative. And for the final value, 4 minus 3 would give me a positive value. 4 plus 2 would give me a positive value. I multiply them to get a positive value. So my solution set is anything where the function is greater than 0, which I have found here at 3 to infinity, and here from negative infinity to negative 2. So I would write my solution set as x is equal to negative infinity to negative 2 union 3 to infinity. And to graph my solution set, I would simply need the negative 2 and the 3, but feel free, if you're a little bit OCD, to put those numbers in between. And maybe some numbers on the outside, not required. But I'm including negative 2 and going to the left, and I'm including positive 3 and I'm going to the right because that's 3 to infinity. This would be my solution set. Now, I can't recall how our textbook does it. Sometimes you will see a circle there, an open circle to indicate that's up to but not including 2. Or you might see it as an open interval. Either way is correct. So you might see it with that open interval instead. Now, I do want to show you something interesting. You're probably wondering, why did I leave this giant space on the right? And that's because I wanted to show you the graph of f of x is equal to x squared minus x minus 6, which you can see is the blue parabola. And then I simply had another function that I said, where is f of x greater than 0? And I can see that it's between negative infinity to negative 2, just as we found, and from positive 3 to positive infinity. Let's take a look at this second question. This one's a little bit tougher because we have not a 0 on the right side, but a 3. So before I can even do any of my normal steps, I actually have to deal with the fact that it's a 3 and not a 0. So I need to subtract 3 from both sides of this function. So on the left side, I have 2x minus 7 divided by x plus 5. And because it's a rational function, I want to be able to combine that 3. So I'm going to say minus 3 times x plus 5 divided by x plus 5. So that's going to make it so that I can combine those values together. And then I'm going to have is less than or equal to 0. By doing some simplification, I have 2x minus 7, and then I have a negative 3 times x, so minus 3x, and a negative 3 times 5, so minus 15, all over x plus 5. And then one more simplification step, I've got negative x minus 22 divided by x plus 5 is less than or equal to 0. So here's my new function. So this is f of x. And now I'm going to start with my normal steps. So step 1, I have to look at the domain, and I have to look at the zeros. So for my domain, I know that the domain is all real numbers, except I can't have the denominator equal 0. So my domain is that I can't have negative 5 as x. For the zeros, I'm going to, and again, I should be clear about that. X plus 5 equals 0, so x is equal to negative 5. That's one of the key values. And for the 0, negative x minus 22 equals 0, so x is equal to negative 22. Again, just by adding 22 to each side and then dividing. So here's my key values. Step 2 is now I have to take those values and separate out my domain. So from negative infinity to my lowest value, negative 22, negative 22 to negative 5, and negative 5 to infinity. And then I have to find a value in those intervals. I'm going to choose negative 25, negative 10, and 0. And again, I only care about the signs, so I'm going to use this version and just look at signs. If I used negative 25, I would have a negative negative 25, or positive 25 minus 22. That would give me a positive, and a negative 25 plus 5 would give me a negative. So this is going to be a negative overall value. Next, I've got negative 10. Negative 10 minus 22 is going to give me a negative value. Negative 10 plus 5 is going to give me a negative value. Negative divided by negative is positive. Lastly, I'm looking at 0. 0 minus 22 is going to give me a negative. 0 plus 5 is going to give me a positive. Negative divided by a positive is a negative. I care only for when that function is less than 0. So my solution is going to be from negative infinity to negative 22, along with negative 5 to infinity. And again, to graph that solution set, I would have negative 22 and negative 5. Oops. And I would be going outward to negative infinity and to positive infinity. And again, we can take a look at the actual graph. We can see that negative 22 is in fact that endpoint, that positive 5 is that endpoint, and now we have our solutions. I do want to point out to you one thing, and that is that negative 22 can be included. We haven't really talked about that yet, but it can be included because negative 22 doesn't actually change, isn't actually undefined, whereas negative 5 will make our function undefined. So if you'll notice on my graph even, this is a solid line, but this is not a solid line. There's no line there. It's just kind of faded. Let's take a look now at an application involving inequalities. This one has to do with profit. The profit function is found by taking the revenue function and subtracting the cost function. So revenue, the amount of money that you're making on a product, subtract from that the cost of making that product, you get the profit for that product per unit. So in this question, we're given a revenue and cost equation. Here's the revenue function, which is x times the quantity of 50 minus 0.0002x. And then we have our cost function, c of x is equal to 12x plus 150,000. R and c are both measured in dollars, and x represents the number of units sold. So in this case, we're asked to determine how many units must be sold to obtain a profit of at least 1.65 million. To begin, we're not even going to pay attention to this part of the question. We're just going to look at the profit. The profit function is the revenue function and subtracting the cost function. Be very careful here as I'm subtracting both values within the cost function. A lot of students forget to distribute that negative. So I'm just going to do some simplification by distributing x, distributing the negative, and simplifying. So this is my new profit function. And now we're going to take into account, we want the profit of at least 1.65 million. So that means this profit function has to be greater than or equal to 1.65 million. So we're going to use the greater than or equal because that's at least. So it's that much or more. And in order to solve this, I of course need it to be 0. So the zero product property, meaning I can either factor it or I can use the quadratic formula. So by subtracting the 1.65 million from each side, I now have my new function. From here, you can certainly choose to factor. I didn't even try to factor this. I went straight to the quadratic formula, plugged in my values because I didn't want to deal with that decimal value. And that gives me two values, negative 38 plus 2 divided by negative 0.0004, and then of course minus 2. And that gives me the two values of 90,000 and 100,000. Just as we did before, now we're going to take our entire domain and separate it out using those two key values. In this case, our domain is not negative infinity to positive infinity. Our domain is 0 to infinity because it wouldn't make sense to have a negative x value or a negative number of units sold. So separating out our domain, we have three intervals. I'm going to come up with three values within those intervals as test points. And again, all I'm going to do is plug them in, use a calculator or Desmos to help you to do that. So use your function to be, where is my function? This function. Nope, sorry, this function. Obviously without the 0. And then plug in 80,000, plug in 95,000, plug in 110,000, and find the signs, which are negative, positive, negative. Now I'm going to take into account the fact that I want it to be greater than or equal to 0. So this is my greater than or equal to 0. My solution is 90,000 to 100,000. And that means the number of units that must be sold to attain a profit of at least 1.65 million is between 90,000 and 100,000 units. Coming up next, we are moving on to Chapter 3. The first section of Chapter 3 is 3.1, Exponential Functions and Their Graphs.